on to the next talk, I will introduce Dr. Kim. So our next talk is going to be performance of applications on Nurion and Nurion utilizing MVAPICH2 software. So this will be presented by Dr. Minsik Kim. He is a researcher in the KISTI Supercomputing Center in South Korea. He received his PhD degree in electrical and electronics engineering from Yonsei University in 2019. And his research interests include deep learning optimizations on GPUs, computer architecture, and HPC. He's also a member of IEEE. So thank you, Dr. Kim. Can you please share your screen? Hello, Dr. Kim. You're actually mute. I cannot hear you.
Hi, can you hear me?
I can hear you now. Yes. Can you please share your slides?
Can you see the slide?
I don't see them.
Okay. Yeah, now you can see the slide.
Yes, can you please make them, full screen? Yes, I can see them now. Thank you.
Good morning, everyone. I'm Minsik Kim from KISTI. KISTI is the National Supercomputing Center in South Korea. I'm working in the Supercomputing Infrastructure Center, whose main role is deployment, operation, and user support for HPC system. So first, I want to introduce our system called Nurion, whose name was decided via public participation in naming context. So, as the National Supercomputing Center, KISTI provides computing resource to Korean researchers and engineers from university, government, and industry since 1988. KISTI has more than 30 years of supercomputing deployment history. So first we start first supercomputer is created to us, and then after 5 years later we introduce second supercomputer grade C9, and after so on we currently production Nurion, which is KISTI-5, and also we have another GPU system which is called Nurion, and KISTI-6 production will start in 2023, and budget is not decided yet. So this slide shows the overall history of our current system. We began our project by constructing new building in 2015, and December 2018 we start putting the main system in full production. So this is our process for the deployment of the supercomputer. So KISTI-6 will be deployed in same building, and now we are in preliminary feasibility study for the KISTI-6. KISTI-5 system is still one of the largest cluster system in the world, even though its peak performance seems to be relatively small right now. It composed about 8,300 KNL nodes, and there's another Scala nodes, which are connected by OPA interconnect. Each Lightning node has 68 cores and 96 DDR4 memory, and also it has HBM memory, which has high speed, high bandwidth. Also, the amount of parallel file system storage is more than 220 petabyte, equipped by DDN exascaler. It also has MVAPICH type bus buffer, which is around 3 times faster than DDR storage. As a bus buffer implementation, the system has 48 servers, with each has 16 NVMe SSD disk and DDN IM solution on top of it. All component nodes, bus buffer and storage are connected by OPA at the same layer. It is the 2-to-1 blocking battery topology. Even though our interconnect is by default 2-to-1 blocking, considering the possibility of heavy traffic between computing node and storage. So we add more cables between core switch and edge switch directly connect to the storage. This slide is show more details version of the interconnect. And these are the benchmark performance results from ISC 2021. Since the system has been in production for about 2 years and a half, Nurion is ranked 31st in top 500, far away from the initial ranking. And also, we have another system called Nurion. Nurion is a GPU system in QST, and it was introduced to analyze the possibility of the GPUs. Especially, it was for the QT5. And after QT5 was confirmed as a KNL-based system, we used this system to support AI researcher and future GPU possibilities in HPC. So Nurion is expanded every year, and in this year, GPU server with NVIDIA A100 was scheduled to deploy in June, but it was delayed due to the disruption. And it is also used as a test bed for QT6. So various accelerators such as AMD GPUs are being used as internal dedicated nodes. So now I will introduce about the performance test on Nurion. So now we are in preliminary feasibility study for the QT6, and as we all know, the possibility that QT6 will be GPU-based system is very high. Although we have another GPU system, Nurion, but it's not suitable for large-scale experiments. So we also conducting MPI performance analysis in Nurion, which is based on existing CPU system. Also, various tests is conducted in Nurion as much as possible. So first we use OS micro benchmark and MPB to evaluate the performance. Next, we evaluate the performance for the HPC application and in-house application. In addition, since QT6 plan to support large-scale and also the performance test was also performed on ML application. First, we evaluate the internal collective communication for the verification of the MVAPICH2 installation. So we newly installed the latest MVAPICH2 library for this test. So we check the 5 benchmarks with MVAPICH2 and compare with previous installed MVAPICH library. So most of the experimental results are similar to the previous installed version in small message case. And also, we evaluate the P2P and internal communication, collective communication for the verification of the MVAPICH2 GDR installation. We check the 5 benchmarks with MVAPICH2 GDR and compare with previously installed MVAPICH2 library. Most of results are similar to the MVAPICH2, but there is some improvement in small message cases. And second benchmark we use is MPB. MPB is implemented MPI only for the HPC, and we use F-class problem for the evaluation. Although there was a slight difference from the existing installed version. There was a 3 point to the 10% faster than previous installed version. And also we compared to the MVAPICH2X, which is XPMN based. In the large scale case, MVAPICH2X is slightly better. And DNS-TBL is KISS in-house application, and it is a direct numerical simulation of turbulent boundary layer. It consists of a velocity server and pressure server, and main objective is to solve the continuity and incompressible Navier-Stokes equation. This code is optimized for the Intel Xeon Pi, and it uses Fortran language. The performance of DNS-TBL is evaluated with following configurations. This application uses MPI and OpenMP hybrid implementation, and each MPI process uses 8 OpenMP thread. Similar to the MP benchmark, the performance implement of MVAPICH 2.3.6 could be observed in entire cases. In velocity and pressure server, MVAPICH 2.3.6 shows better performance compared to the other implementation. In update velocity and pressure, it shows a similar performance compared to the other cases. And LAMMPS application is one of the molecular dynamic simulation application. We tested RODO benchmark, which models rhodopsin protein in a sorbated lipid server by layer. This benchmark composes a pair, bond, K-space, neighbor, output, modify step. We used a recent version of the LAMMPS. So the following, the performance of the LAMMPS is evaluated with following configurations. We tested the LAMMPS with MPI only implementation. The performance improvement of MVAPICH 2.3.6 could be observed, but overall performance gain is not much as other cases. Since the LAMMPS use the most of the memory space in KNL and HBM in our system is usually utilized with cache, so there was a performance degradation with based on with XPMM. So in case of the LAMMPS application, GPU version was provided, so we were able to test it on Nurion, which is a GPU system, with MVAPICH2 DDR. Due to the limitation of the GPU memory capacity, it was difficult to conduct large-scale experiments. So we test the LAMMPS with MPEG's CUDA implementation. It shows some performance gain and scalability, even in small problem cases. But it was hard to fit large problem on V100 node in Neuron. So we will try to again after the A100 basis server is deployed. At last, we evaluate our system performance on the ML application, which is called CosmoFlow benchmark. In terms of scalability, both Nurion and Neuron was able to obtain sufficient result. And since the CosmoFlow benchmark uses a very large data set, the performance was highly affected from storage. So currently, Neuron uses the legacy of the 64 storage. So when we test this benchmark with other storage with Neuron, we found that this part had performance drop. So we have evaluated several tests on Nurion and Neuron. So first, there was additional performance gain improvement with MVAPICH2 version upgrade in Nurion. We could use this result for the performance prediction of the KST6. Second, we successfully tested the MVAPICH2 GDR on Nurion. Due to the system scale, it has a less effect on application performance compared to Nurion. But additional experiment will be proceed after the system extension is completed. So in the future, we should decide benchmark candidates and we make expected performance for the KST6. Then this experiment will be helpful. Thank you for the presentation.
Excellent. Thank you, Dr. Kim, for your talk. That was insightful. So before I go to audience questions, so some of the numbers that you presented, they were taken with 2.3.5 version of MVAPICH2 GDR, right? So we do have newer releases for the GDR software. So have you tried those, or is this the version that's installed and was used?
In this experiment, we use 2.3.4.
Okay. So we actually recently, couple of weeks ago, our team made 2.3.6 release. So maybe you can, there are a lot of optimizations done in those. There is support for compression. So there are many new features in that software stack. So maybe you can use that as well, right?
Okay, thank you for the information.
Sure, excellent. And so how about this high bandwidth memory? Is this Intel Optane memory that's installed in KST5? So how is that used for applications? Is there any specific optimizations done for the application?
It's not Optane memory, or it's HBM.
Okay.
And we use this HBM as a cache for the DDR4 memory.
All right. Okay. Okay. Okay.
Yeah.
Okay. So are there any specific application level optimizations done for, utilizing this high bandwidth memory? Are the applications using this memory?
Basically, we use this in cache, but we have also other queue for the application optimization. Like in flag queue, you can see other memory like HBM and DDR4 memory.
Okay. Okay. That sounds good. Let me see if there are any questions on Slack. So, okay. So, and I also saw a graph, I think it was slide 14. Can you, so it was doing a comparison between MVAPICH2 GDR and the MVAPICH software. So, so here, what exactly is this comparison? Is this comparison done for the GPU buffers or data inside GPUs?
It's GPU to GPU. So first three P2P internal communication is for the two different GPU nodes.
All right. Okay.
Yeah. And other three graphs for the four other GPU nodes with collective communications.
Okay. Okay.
We just test for the verification of the proper installation.
Okay. Okay.
Can you hear me?
Yes, but Bharat, do you have a question?
Yeah, I have a question. So sorry, Dr. Kim, so I think I missed a couple of portions because my internet wasn't working. So can you just clarify like one thing for me? So the KISTI supercomputer has an InfiniBand installment, and the Nurion supercomputer is PSM, right?
So Nurion supercomputer has OPA interconnect.
Okay.
GPU system Neuron has InfiniBand interconnect.
Okay, so in your evaluations on Neuron, it shows that you've done MVAPICH2 comparisons for CPU. Did you get a chance to try MVAPICH2X?
Yeah. We also have tested MVAPICH2X before. Yeah, and
No, I mean on the graph on the previous slide. So it says MVAPICH2 2.3.6, right? So I think it should be slide 16 or 14. I'm not sure.
It was maybe previous version. It's not 3.6.
Okay. Okay. So okay. Okay, I think, yeah, that should be okay. It might just be an issue with my display. I'm sorry. Yeah.
Yeah.
Okay. Okay. Thank you, Bharat. Are there any other questions from the attendees? Please post them on Slack or, on the Q&A. So I know you presented the future roadmap for the KISTI 6 system. When will that be coming online?
So it's not dedicated yet, but we expected the scale is 0.5 exa plus, or from. I'm not sure.
Okay. Okay.
And it will be most of the part will be GPU system.
All right. Okay. And do you know which GPUs will it have? Do you know which GPUs or which accelerators will it have? Or will that be
It's very
decided?
hard to talk about that because
Okay.
we are not selecting the vendor.
Okay.
So we make benchmarks and other vendors or contact, and
Okay.
yeah, so that's why we really hard to make benchmarks.
Okay. Okay.
Yeah.
Okay. So with that, Dr. Kim, I would like to thank you once again for your excellent talk. And I think I will move on to the next talk. So our next speaker is Dr. Hyung Wook Jin, and he will be giving us a talk on the energy efficiency of MPI intra-node communication. He's a professor in the Department of Computer Science and Engineering at Konkuk University in Seoul, Korea, where he's leading the System Software Research Lab. And before joining Konkuk University in 2006, he was a research associate in the Department of Computer Science and Engineering at the Ohio State University. He received his PhD degree from Korea University in 2003, and his main research focus is on operating